In every era of human civilization, tools were created to solve problems, to survive, and to shape the path of our species. But among all the tools ever invented, few have influenced history as deeply or as controversially as the firearm. A device small enough to be held in the hand, yet powerful enough to shift empires, defend nations, and alter the fate of individuals. This is the story of what a firearm truly is, beyond the myths, beyond the fear, beyond the fascination. And in this first chapter, we dive into the foundation, the basic science, the inner workings, and the identity of the firearm itself. To understand firearms, we must begin long before the age of modern warfare, and long before machines filled with steel and precision engineering dominated the battlefield. The origins lie in fire, pressure, and the relentless human desire to create controlled power. At its core, a firearm is a simple concept, a tool designed to launch a projectile using the rapid expansion of gas. That's it. A mechanism that transforms chemical energy into kinetic force, pushing a bullet through the air faster than the eye can see. But what appears simple on the surface is, in truth, the result of centuries of engineering, experimentation, and evolution. A firearm is not defined by its shape, its reputation, or its presence in culture. It is defined by its components and by the scientific principles that allow it to function. To truly understand firearms, we must strip away the Hollywood glamour and the dramatic myths and focus instead on the machine itself. A firearm, in its most basic architecture, consists of a barrel, a chamber, a firing mechanism, and ammunition designed to fit within it. These elements, working in harmony, create the controlled explosion that sends a bullet downrange with immense speed and precision. The heart of the firearm is the ignition. Everything begins with pressure, created by the burning of gunpowder inside a sealed space. When the trigger is pressed, the firing mechanism strikes a primer on the back of a cartridge. This primer ignites, creating a spark that sets off the powder within the casing. The powder burns rapidly, not exploding outward, but expanding into hot, high-pressure gas. Because the bullet sits at the front of the cartridge and the casing is held tightly in the chamber, there is only one direction for that gas to escape: forward. And so the bullet is driven out of the barrel, spinning, stabilizing, and accelerating into the world beyond the muzzle. This reaction happens in thousandths of a second, yet the consequences are massive. A small piece of metal, sometimes no heavier than a few grams, can travel hundreds of meters, strike with immense energy, and land precisely where the shooter intended. It is this combination of power and control that defines the firearm, and that has made it one of the most influential technologies in human history. But to grasp what a firearm is, we must understand not only the mechanics, but the language that surrounds it. There are categories: pistols, rifles, and shotguns, each with unique characteristics shaped by centuries of adaptation. A pistol is designed to be held and fired with one hand, compact and maneuverable. A rifle, by contrast, is built for precision and distance, using a longer barrel and rifling, spiral grooves cut into the interior to stabilize the bullet in flight. Shotguns operate on a different principle altogether, firing shells filled with pellets that spread outward, or a single large slug for powerful close-range impact. These categories are not arbitrary. They represent different engineering philosophies, different use cases, and different eras of human need. Throughout history, firearms evolved as society changed, from the early matchlocks that required burning fuses, to flintlocks that sparked ignition, to cartridge-based systems that revolutionized speed and reliability. In the modern world, firearms have become complex machines, using materials like polymer, forged steel, and aerospace-grade coatings to withstand extreme conditions. But despite all the advancements, the core principle remains unchanged: controlled force directed through engineering. To understand firearms at the beginner level is not to glorify them nor to fear them. It is to learn their behavior. Every machine has a purpose, and every tool carries responsibility. For enthusiasts, collectors, historians, or simple learners, understanding a firearm begins with respect for its power and awareness of its limitations. This foundation is what separates knowledge from ignorance and informed understanding from dangerous assumptions. But before we move deeper, before we explore calibers, mechanisms, ballistics, and the global evolution of weaponry, we must return to the core question: what makes a firearm function? The answer lies in the controlled explosion. Without pressure, without heat, without a sealed chamber, a firearm cannot operate. The engineering of these components is what turns a simple spark into directed force. The barrel contains the pressure. The rifling stabilizes the projectile. The firing pin initiates the process, and the ammunition carries the chemical energy that makes everything possible. Modern ammunition is itself a masterpiece of engineering. A single cartridge contains 4 essential parts: the casing, the primer, the powder, and the projectile. Each one is designed with precision, measured in fractions of a millimeter. The casing holds everything together. The primer reacts instantly when struck. The powder burns in a controlled chain reaction. And the bullet, shaped to reduce air resistance, follows the physics of motion with extraordinary consistency. Without ammunition, the firearm is simply an empty shell. Without the firearm, ammunition is simply inert material. Together, they create a system more powerful than either part alone. This relationship between firearm and ammunition is what has driven innovation for centuries. As metals improved, bullets became more aerodynamic. As chemistry advanced, powders became cleaner, faster burning, and more efficient. As machining reached new levels of precision, barrels became capable of launching bullets farther and with tighter groupings. The firearm, in its modern form, is no longer a crude tool of survival. It is a refined instrument, a device shaped by science, physics, and human ingenuity. Yet despite this sophistication, the core concept remains accessible. Anyone can understand the basics. A firearm directs energy. A trigger initiates a chain reaction. A bullet travels a path determined by physics, gravity, and air. These principles apply universally, from the smallest .22 caliber pistol to the mightiest long-range rifle. The scale changes, the materials change, the purpose changes, but the underlying science does not. But a firearm is more than just science. It is a cultural artifact. In many countries, firearms have shaped national identity, influenced military conflict, and even impacted the evolution of law and governance. In the United States, firearms are woven deeply into the cultural landscape through history, sport shooting, self-defense, and constitutional debate. In other parts of the world, firearms represent security, military strength, or historical transformation. To discuss firearms globally is to explore more than machines. It is to study the human stories behind them. And so, when a beginner asks, "What is a firearm?" the answer is layered. A firearm is a machine of controlled energy, a bridge between physics and engineering, a tool of defense, a symbol of strength, and at times a subject of deep ethical debate. It is simple in principle, complex in detail, and powerful in its application. As we move forward in this series, we will explore the details that define the world of firearms. We will examine the evolution of technology, from early black powder muskets to modern-day semi-automatic platforms. We will uncover the science of ballistics, how bullets travel, why they behave the way they do, and what determines accuracy. We will explore global designs, legendary models, and the innovative